Hello students, welcome back. Let us continue our chapter number 2 of geography, that is the interior part of the earth. In the previous lecture, we studied initially the earth was very hot and gaseous. The scientists took efforts to study the materials coming out of volcanic eruptions. We also studied that three main layers of the interior of the earth such as crust, mantle and core. Dear students, today we are going to learn about crust in detail. Let us see the crust. The crust, the uppermost layer of the earth's surface, is in solid state and is called the crust. Dear students, the uppermost layer of the earth's surface or the uppermost layer of the interior of the earth is called the crust. It is in solid state. The thickness of the crust is not the same everywhere. It means the thickness of the crust is different everywhere. On an average, it is 30 to 35 kilometer thick. The thickness of the crust below the continents is from 16 to 45 kilometer, 40 kilometer under the mountain ranges and less than 10 kilometer under the oceans. My dear students, here the thickness of the crust below the continent, under the mountain ranges and under the oceans are different. As we move deeper under the surface, temperature increases. After that, the rate of increase in temperature reduces and again increases in the core. At the center of the earth, the temperature is around 5500 degree to 1600 degrees Celsius. The crust is the thinnest of all the layers. If we compare to the mantle and the core, it can be divided into two sublayers, such as continental crust and oceanic crust. Dear students, in this figure, we can see the continental crust and oceanic crust. Now, this continental crust, it is made up of many different types of igneous, metamorphic and sedimentary rocks. Whereas oceanic crust is made up of silica and magnesium. That is Si plus Ma is equal to Sima. Now, we are going to learn about the characteristics of continental crust. The continents are mainly composed of silica. It is Si and aluminium means Al. Because of their high proportion in this layer, the layer was earlier known as Cl. My dear students, here continents are mainly composed of silica and aluminium. So Si plus Al is equal to Cl. Yet the main material consists of the continental crust are silica and aluminium. Means Si plus Al is equal to Cl. Dear students, the density of continental crust is 2.65 to 2.90 gram per centimeter cube. The thickness of this layer is approximately 30 kilometers. We can find in this layer granite rocks. Now let's see the characteristics of oceanic crust. Oceanic crust is the second layer of the crust. It is made up of silica means Si and magnesium means Ma. It is earlier called SEMA. The students, the main material consists of the oceanic crust are silica and magnesium. It means Si plus Ma is equal to SEMA. So it is known as SEMA. This layer is approximately 7 to 10 km thick. The density of this layer is 2.9 gram per centimeter cube to 3.3 gram per centimeter cube. In this layer, basalt and gabbro rocks are mainly found. Dear students, in the continental crust, we can find the granite rocks, whereas in the oceanic crust, we found basalt and gabbro rocks. Now, elements found in various layers of the Earth's interior. Silica means Si, aluminium means Al, again silica means Si, magnesium means Ma, nickel means Ni, and ferrous means iron means Fe. The students, here as we move to surface of the earth, we can find the density is rises. In the same way, as we move to the center of the earth, we can find the temperature is increase. Dear students, now we are going to learn about the second layer of the interior of the earth, that is mantle. Below the crust lies the mantle. Mantle can be divided into two layers, upper mantle and lower mantle. The upper layer is more in liquid state. My dear students, upper layer is in liquid state. Here we find magma chambers. It is through these chambers that magma comes out on the earth's surface during volcanic eruptions. My dear students, when volcanic eruptions will occur, the magma comes out on the earth through these chambers. So this layer is also known as asthenosphere. Epicenters of deep seated earthquakes are usually found here. Mantle begins at a depth of around 42 km from the Earth's surface. The next characteristics of the mantle is the internal energy released due to endogenetic movements which is occurring in this layer, and it is responsible for mountain building, rifts, volcanic eruptions, earthquakes, etc. In this layer, it is inferred that the temperature at a depth of 2400 to 2900 km depth would be around 2200 degrees Celsius and 2500 degrees Celsius. My dear students, here there is a sudden change in the structure and density of material. It is estimated that this layer extends up to a depth of 2870 km, and the average density of this layer, means mantle layer, is 4.5 gram per centimeter cube, and it increases with depth. Increasing pressure is the reason behind this. The density of lower mantle is about 5.7 gram per centimeter cube. My dear students, in short, the mantle divided into two layers, upper mantle and lower mantle. The upper layer is more in liquid state, and here when volcanic eruptions were occurred, during this time the magma comes out on the earth's surface through these chambers. So this layer is also known as atmosphere. Remember, my dear students, mantle begins at a depth of around 42 km from the earth's surface. Dear students, I hope you understood the part of this chapter. Remaining part of this chapter, that is the last layer of the interior of the earth, that is core, we will learn in our next video. Thank you and have a nice day.